In this chapter, we will discuss what is the ARP mechanism process, how the address is resolved, okay, and then the ARP cache table. What is the ARP cache table? Okay. First, we know now there's two devices, host A and host B in the network. They are connected together. And then when the host A wants to send in the packet to the host B, so the host A must know the IP address of itself, okay, and then the IP address of the destination, someone must tell him, then this is the source IP and the destination IP. But then when this IP packet sending out to the media, to the network, it must be encapsulated with a layer 2 frame, okay, layer 2 frame. But in the layer 2 frame, the FCS is calculated by the content, and then the Ether2 header, there is source MAC address, destination MAC address, of course the type. Of course the type is decided by the packet inside this frame. In the source MAC address, just the MAC address of itself. Then what is the destination MAC address? The host A did not know what is the MAC address of host B. So we need a mechanism. This mechanism just ARP, okay, Address Resolution Protocol. Then what is the format of ARP? The ARP just encapsulated in Ether2 frame. Okay, of course the type is 0806. Just to point out, this is an ARP protocol. Then in the ARP protocol, this is the format. And then first is the hardware type. Of course, usually just the Ethernet, okay, Ethernet. And then the protocol type, of course, usually it's IP, okay, it's IP. The IP result to Ethernet address, Ethernet MAC address, okay. And of course, the ARP can support other protocols such as IPX or other protocols. And then the hardware length, that means the hardware address maybe have different lengths. Of course, nowadays we usually use the MAC address. MAC address, that's the hardware address. The MAC address is 48 bit long, okay. And then the protocol length, of course, the protocol address length, the IP address is 32 bit long, okay. Then the operation code. In the ARP, there are two operations. First is the request. Want to know your MAC address. I want to know. That's a request. And then the reply. Yeah, answer to the request. This is my MAC address. Okay, that's easy. And then in the content, this is the source MAC address, source hardware address, source protocol address, and then the destination MAC address and the destination MAC protocol address. Okay. Then when the device, host A, wants to send a packet to host C, for example, in this network, of course, this network, there are many other hosts, host B, host D, and others. Then the host A knows the source IP address and the source MAC address. Of course, someone will tell him the destination IP address, but the MAC address host A did not know. Then the ARP protocol will sending a request. Okay, first, the host A will check on its cache. We can also check what is in its cache. Use the ARP -A. Then there's a list of the MAC address and IP address corresponding to currents. But now there's nothing. There's nothing. So if there's nothing, then host A will sending the request out. Okay, then sending a request out. This is the request. And first, the host A sending a request is the ARP protocol. Okay, in this ARP, then source IP and source MAC it's itself. Host A's IP and host A's MAC address. But the destination IP and the destination MAC is destination IP. Destination MAC, because it did not know, so filled with all zeros. That means did not know. But the operation is request that wants to know, I want to know. And then this ARP also needed to encapsulate with the layer 2 frame. In the layer 2 frame, the source MAC address, of course, source MAC address just the MAC address of host A. And then the destination MAC address still not know. Then what MAC address should be used? We can see all ones, FFFF. That's all ones. The all ones means what? Yeah, in the previous chapter we have discussed all ones means broadcast. Okay, broadcast. That means this frame sending out to the network should be received by all the other devices. Host A, host C, or other host D, host E will all receive it and process. And then this packet reached all other devices. Then the all other device gets this ARP request, then got the basic information that this is sent by the source IP, by this 10.0.0.0.1 host A. And then the host A's MAC address also exists in the ARP request. Okay, so the host C and all other devices, host B, will got this information in its ARP cache. Okay, when the host C wants to send packet to this destination, it is not to resolve the address again. Okay, the ARP cache simplifies the operation. Okay, and then all the other devices also receive it, but then the host C or host B will compare in the request. There's a destination IP. Okay, the destination IP is 10.0.0.3. Okay, then the host B received it. We'll see my IP address is not equal the IP address requested IP address in the ARP request. So host B just drop it and not reply. But host C see that the request IP address is equal to the IP address of itself, then host C will reply. Okay, will reply. And in this reply, its MAC address will filled in. Okay, filled in the ARP reply message. Okay, and then this is the reply message. In this reply message, then destination is the host A. Destination IP address host A. Source IP is host C. And then destination MAC address, source MAC address. Okay, then this is the reply. And then the encapsulated use the Ethernet frame. Destination MAC address just the MAC address of host A, and source MAC address just the MAC address of host C. Then host A will receive it to see the MAC address itself, then receive it, and then see this is an ARP request, ARP reply, then will accept, and then got the information, the IP address, this is a pair, and the MAC address, this is a pair. Then host A can sending out the packet to the network, and then the encapsulation is finished. Okay, this is the whole process of ARP. Of course, when the host A gets the reply, then this information also will put into the ARP cache. Okay, of course, the ARP items in the ARP cache, of course, there's types, static or dynamic. The dynamic just means this ARP cache item is learned from the ARP reservation, okay, from the ARP process. So this dynamic means there's a period. After this period, then this item will be deleted. Okay, this item is not permanent. Just means only exists in the host A's ARP cache for one period, for some seconds or some minutes, depending on the operating systems. Okay, then this ARP item will be deleted. Okay, and then this is the common process of ARP, but sometimes we got some special ARP process. Okay, there's two special ARP process we discussed. First is the proxy ARP. Proxy ARP. As we know, the ARP request is sending by broadcast. Okay, the broadcast, the O1's MAC address, the broadcast only exists inside one LAN. That's the only exist in layer 2 network. So the router will not forward the ARP request. For example, the host A is sending the ARP request in this network. Then the host B in that network, in the second network, cannot receive this ARP. The router just drop it. Okay, so if we in such a scenario, okay, in this scenario, first we should pay attention to the mask length. Okay, in this mask length, this is 8. That means the 10 for the host A, the 10 is the network part, and the rest of the 24 bits are all host parts. And host B is the same. The 10 is the network part, and the rest of the 24 is the host part. So when the host A wants to ping the host B, for example, 10.2.0.1, yeah, the host A will regard the network part is the same. Okay, so the host A will think the host B is in the same network. So the host A will not sending a packet to the gateway, just sending ARP request in the same network. But in the true scenario, in this scenario, the host A and host B are not in one network. So the host B cannot receive. But if this router is enabled proxy ARP, that means the router receives the ARP request in G000, this interface, Gigabit Ethernet 000 interface. Then the router will know this is an ARP request in this network. Yeah, this mask length is different. So the router will find the ARP in itself. Of course, if itself did not have, then the ARP, the router will relay the ARP to this network. Yeah, this is the first step. The host A sending ARP in this network, and then the router relayed it. Of course, by default, the router will not relay, just drop it. If you enable the proxy ARP on this router, this interface, then the router will relay the ARP request to this network. Then host B received the ARP request, then reply. And then after the router received this reply, then the router will reply to the host A. But in this reply, the MAC address is not host B's MAC address, but the G000's MAC address. So after that, the host A will sending the packet, and then with the MAC address, destination MAC address is G000's MAC address. Then this packet sending to the network, the router will receive it because the destination is routers. And then router receive it and then see the destination IP address. This IP address is host B's. Then the router will route this packet to host B. Okay, this is the proxy ARP. Yeah, in this proxy ARP, we should know here there's something special. This mask length is 8. This mask length is 8. And this mask length is 16. This mask length is 16. Of course, this scenario, I think, is not commonly used in our network. This scenario just to illustrate, to show you in which scenario the proxy ARP will work. Okay. And then another useful ARP, special ARP is gratuitous ARP. What is gratuitous ARP? In our common ARP, when a host wants to get the information of the destination's MAC address, then sending ARP request. But gratuitous ARP is different. The purpose of gratuitous ARP just to detect if the IP address there's a collision. That means there's another device use the same IP address in this network. For example, this host have configured this IP address. Then this host A did not know if there's another device also configured this IP address. That means there's an IP address collision. Then what can host A do? The host A just sending an ARP request. In this request, okay, the source IP, the destination IP, the source IP, and then the destination MAC address, and then the source MAC address. Okay, all 0. And then to know if there's another device use this IP, because in this ARP, the destination IP is this IP address. If there's another device use this IP address, then this device will reply. If there's a reply, then host A will know, aha, there's another device use this IP address. So the IP address is collision. So I cannot use again. So host A will hold, not hold the state of the NIC network interface card. Okay, and gratuitous ARP is useful when you assign a new IP address or get a new IP address in the NIC card. Okay, this is gratuitous ARP. Okay, and then we have discussed the scenarios of the ARP protocol used, and then there's 2 questions. First, prior to generating ARP request, what does the host, does the end station do? First is to look for the destination MAC address in the ARP cache. Okay, ARP cache. Every device have built an ARP cache. Then, if you can find the destination IP in the ARP cache, just use the MAC address in the ARP cache. If cannot find the destination IP, then sending out an ARP request. Okay, the ARP request is currently in the broadcast. Okay, and then when a gratuitous ARP message is generated and sent to the network, the gratuitous ARP I have discussed that's used to detect the duplicate IP. That's IP address collision. Then, in which scenario? Just you change the IP address of a host, of a device, and then all the hosts have get a new device. Then need to use gratuitous ARP to detect if this new IP address is duplicate with another device. Okay,